Okay, in this problem we're going to raise the bar a bit. So we're going to determine how many molecules of N2 we can make from 10.0 grams of NaN3. Now, here's what I'm going to ask you to do. Pause the video and come up with a strategy for how you're going to do this problem. It's going to require a few steps. Pause and come up with your strategy now. Okay, so here are the pieces that I've got for my plan. We're going to determine the molecular weight for the NaN3. From that, we're going to be able to find out the number of moles that we have of NaN3. From moles, I can find out how many molecules I've got. From that, I can find out how many atoms of N I've got. And from that, I can find out how many molecules of N2 I'm going to be able to end up with. So that's the plan that I've come up with for this problem. Now let's go ahead and execute this. So for the first part here, I've got to determine the molar mass of NaN3. So Na, N, I have 1, I have 3. For sodium, the molar mass for it is going to be 22.99, and for nitrogen it's 14.01. So I've got everything laid out and ready to go. So what I can do is I can solve for this. I know this is going to be 22.99. Now I'm going to go ahead and do my 14.01 times 3. It's going to be 42.03 plus the 22.99. So it's going to be 65.02. Okay, and this is going to be the layout for it. So we're going to have, multiplying all the way across, 22.99 for the sodium. For nitrogen, we had the 42.03. We add them together and we get 65.02. We chop off after the last place and nothing happens in this case. This is going to be our molar mass. So we're going to have 65.02, I'm going to get rid of this, grams per mole. Okay, now I'm going to go ahead and erase the screen so that I have some room to work for the next part of the problem. Next up, I've got to determine the moles of NaN3. So I have 10.0 grams of NaN3. That looked a little like a 6, so let's fix it. There we are. So I need to get rid of grams. I need to get into moles. Now I've got 65.02 grams in 1 mole. That's what's in this conversion factor. My grams have cross-canceled. I am now in moles, so I can just do 10 divided by 65.02. Okay, so we'll have our 10 divided by 65.02. Nope, by 02. There we are. And we get 0.01537, well, 01538. 01538. 0.01. Wait. Yeah. Okay, and it's going to be in moles of NaN3. Okay, now I've got to fix my sig figs on that. I should only have 3 sig figs. So over here for my answer, right here, I'll put 0.0153. I'll subscript the 8 so that I know that it's not significant and that it should have been rounded up to 0.0154, but that we're retaining it for subsequent steps. I'm going to get rid of this to give myself room to write this. So we're going to have moles of NaN3. Okay, so far we've got about half of the problem done, really. Next up, we've got molecules of NaN3. Now to do that, I do moles into molecules. 0.01538 moles of NaN3. Got to get from moles into molecules. I'm going to abbreviate it molic. So I'll have 1 mole of these equals 6.022 times 10 to the 23rd. Okay, now we're going to go ahead and grab our calculator. We have this number. It'll just be times 6.022 times 10 to the 23rd And it's going to be an ugly looking number. It's going to be 3, 6, 9, 12, 15, 18, 21. So 9.262. 9.262 times 10 to the 21 I just described. Okay, so that's going to be the number of molecules of NaN3. Now, let's give it a quick reality check. I'm at about 1/100th of a mole. So I expect to be 2 orders of magnitude less than Avogadro's number. 6.022 times 10 to the 23rd. I'm in the 21st. Seems pretty reasonable to me. I'm going to get rid of this for room again. We have 9.262 times 10 to the 21 molecules of NaN3. Next up, we got to get into atoms of nitrogen. Well, how many nitrogens do I have? I've got 3 in each of these. So if I multiply it by 3, I'll know how many molecules I've got, how many atoms I've got. I'm going to do this the easy way. I'm going to do 9.262 times 3. So I'm going to write it like this for a second. I'm going to write it dirty, and then I'm going to write it clean. 27.786 times 10 to the 21. I'm going to move it over one place, so it'll be times 10 to the 22. So 2.7, let's see, and then, oh yeah, I had to fix my sig fig right there. Let's just go ahead and drop cap that. There we are. Oops. Here we are. That's better. Now we can keep going with this. I have 3 sig figs to retain for this. I have 2.77. Make that look more like a 2. There we are. And then I'm going to have to drop cap the 8.6 times 10 to the 21 atoms of nitrogen. So we're almost there. Last step. I need to use 2 atoms to make this molecule, right? So I'll divide it by 2. So I'll grab the calculator again. So that divided by 2 gives me 13.893. 13.893. And remember, that was when I was cheating so that I didn't have to deal with my calculator being terrible about scientific notation. So that was times 10 to the 20. So I'd be at 1.3893. Oops. Here we are. Times 10 to the 21. It's just like before. Molecules of N2. Time for me to circle my final answer. Now I don't want to use this anymore. I want to say 1.39 times 10 to the 21st molecules of nitrogen. And that would be our final answer. You can see that it had a few steps to it. But if we break the problem down conceptually, it's pretty easy for us to put together. We could have also chained all of that together into a single long set of fence posts. And that's how I actually would do this with pen and paper. But look at my handwriting on the screen. It's already bad enough, right? So I broke it up so that you'd be able to see it modeled that way instead.